There's a topic in audio production that I'm really interested in, but of which I've never seen a demonstration, and that is using a Blumlein stereo pair to record musicians in a 360-degree circle around the microphones. So I've seen this topic mentioned, discussed in forums quite a few times, but I've never seen it demonstrated. So I'm going to do that for you today and demonstrate why I would not use it. So my circumstance is there's a brewery near me that hosts a bluegrass jam session once a month. And so, 10 to 20 musicians come in, form a circle, and play bluegrass together. And facing the center of the circle, obviously. So the obvious place to put the microphones, a stereo pair, is going to be somewhere in the center of this circle. And if you go onto forums and ask for advice, invariably there are going to be one or two people who say, use Blumlein because it's great. It gets 360 degrees. And again, I'm going to demonstrate today why I would never use that. So I have a Blumlein pair set up behind me, and I'm going to go just briefly into what Blumlein is. If you don't know what it is, you probably should watch another video because I'm not going to go very far in depth. But if this chart is looking from above, and so this would be where the microphone stands would be, and we're looking down from the ceiling. This would be like center stage on a typical setup. So Blumlein is 2 figure-8 mics, coincident pair, and one mic is 45 degrees left, pointing 45 degrees left, and the other mic is pointing 45 degrees right. And you're going to pan these hard left and hard right. And this is a coincident pair, which means that their diaphragms are as time-aligned as we can possibly get them. And so what that means in setup is that you have one of these mics suspended upside down over the other mic. And again, twisted 45 degrees to the right and left. So since these are time aligned, or since they are coincident, the stereo imaging here is going to come 100% from intensity differences between the two channels, as opposed to time differences. So when a sound source is directly in front of our pair of mics, what we're going to call the front, the levels coming into channel 1 and channel 2 are going to be almost exactly the same. So our brains are going to tell us when we hear this reproduced in speakers or in headphones that this sound source is right in the center. And if the sound source is maybe 20 degrees to the left, that means that channel 1 is going to be a little bit louder than channel 2. Therefore, we're going to perceive it as slightly to the left. And that works all the way up to 45 degrees left and 45 degrees right. Pretty much everything I say on the left side works on the right as well. But once you get to 45 degrees, you're going to be 100% in the sweet spot, or the most sensitive part of this microphone, and you're going to be in the null of channel 2. So if this were a point source and you were in an anechoic chamber, that means there'd be no sound going into channel 2. Of course, that's not reality, but effectively you have almost no sound going into 2. You have just basically room reflections, mostly. So this is going to sound like it's 100% in the right speaker, for the most part. And that works, again, on the right side. So that's all well and good, but what happens if something is on the other side of this, behind the microphones, from negative 45, or from 135 to 225, whatever that is. So if a sound source is right here, again, you're hitting the back side of these mics, but since you're right in the center, the levels will be the same, and figure eights sound identical front to back, unless you have one of the mics that has a slightly different EQ, like some of the ribbons have that, but that aside, it's going to sound just as good as if you were in the front. And since the levels are going to be the same, it's going to be centered. However, if you're 20 degrees over here, what we call the left on this side, you're actually hitting hotter into channel 2. So this is going to sound like it's on the right side in our stereo image. So if we were just calling this our stereo imaging here, anything down here is going to actually sound like it's over here. So for example, if you were going to record a double string quartet, you might be tempted to put violin, violin, viola, cello, and then on the back side, violin, violin, viola, cello. But you just have to know that this cello is going to sound like it's on the left side. So if you want both your cellos on the same side, You actually have to mirror image the bottom half here. So it'd be cello, viola, violin, violin. You get the idea. And there's nothing wrong with that. It can be maybe a little bit weird if you're recording this, but it would be a strange recording anyway, because where are you going to video this from? Above, you're going to have some jump cuts and weird placement anyway. But it's going to sound perfectly fine. Okay, so if we break this into quadrants, you have quadrants 1, 2, 3, and 4. Quadrants 1 and 3 are perfectly fine as long as you understand the reversal of the stereo image on this side. You're perfectly fine. However, quadrants 2 and 4 are problematic. So when you're here at 45 degrees, you're 100% in channel 2, which is the right side, effectively. And as you move farther this way, though, as you come back over to, or you come up to 90 degrees, suddenly you are the same intensity to both mics, but you're on the back side of channel 1 and the front side of channel 2. So therefore, the polarity is going to be reversed from channel 1 to channel 2. So while the intensity is telling your brain it's in the center, the polarity reversal is going to lead to phase issues, which is going to confuse you. It's going to be an imprecise stereo image. So anybody over here is going to suffer from that. The ones nearer 90 degrees and 270, the instruments here are going to suffer the most, I think. And you'd have to try this to actually know how it works. But at this point, when you're here, when the intensities are the same between the two mics, you're really going to have phase issues. The closer and closer you get to 45 and 135, though, you're losing one of these channels effectively. So phase issues would be less audible, I guess you'd say. But I would call this entire quadrant problematic. I wouldn't want to use it. Well, and it's an interesting question, though, because when you have 10 to 20 musicians in a circle, things are going to get a little crazy anyway. But I would not want to start with something that is already, there are phase issues, serious phase issues. So I guess serious polarity issues. I'm normally pretty good with using those two distinct terms accurately, but I get a little confused when we're talking about a coincident pair here. Okay, so I've demonstrated in theory why I would not use these two quadrants, but now let's go ahead and do a demonstration of it. So behind me, I have, I don't have an image of this, but I have a mic stand with a Blumlein pair on it. So in a moment, I'm going to turn around and we're talking into those mics, and what I'm going to do is start at the center, start at 0 and work my clock way around this Blumlein pair, so you can hear every quadrant and every 45 degrees what it sounds like. And while I'm recording that, what you're also going to see here is to help kind of back up what you hear. I'm going to have a phase correlation meter running, actually 2 of them. So I've got 2 meters here on the master bus. One is called stereo phase scope, which is this guy, and then I've got stereo phase correlation meter. These essentially do the same thing. This guy just does one more little graph here. So as I speak, obviously I'm speaking into a single channel mono here. I'm going to go ahead and turn automation on for just a second of panning. So in a mono track, you're not going to have any phase issues, but we'll just pretend for a second this is stereo. As I'm speaking, you can see I'm hitting +1 on this little gauge, and the same thing over on this needle, hitting +1 in the green. As I stop speaking, it goes back down to 0. So this is not left-right, this is phase correlation. So when you have 2 or more channels, and we have left and right here, you have phase correlation between them. And for example, if you're using, say, a spaced pair of omnis to record something, these meters move around quite a bit, just depending on where in the stereo field instruments are and how heavily they're being played. You're going to see things moving around a bit. In general, for what I would call true reproductions of acoustic music, so I'm going to group together things like bluegrass, vocal music, church music, orchestral, where we want a true reproduction. You don't generally want to be down in the negative much, because that is true phase or polarity reversal when you get to -1, or some phase issues. So you can have certain effects that you can apply, especially to popular music, that makes use of phase and polarity reversals and things like that. But for the most part, you want to be in the positive one up here. And as I said, since I'm mono, this test that I'm going to show you makes very little sense, but it'll make more sense once I get into Blumlein. But the additional thing this meter shows is how far left and right we are. Since I'm a mono source, it is pretty much just a pinpoint coming out front and rear there. And it shows me I'm full right now, and I have pretty much a pinpoint source, which is mono. And you see one little thing that's weird here about this, when you pan all the way to the right, we have no phase correlation because there is no left channel. So that's a little bit of a special anomaly there. But if you go, say, half right, you can see, even though the levels are quite different here, the phase is still +1. And again, with mono, that's all you're going to get. I can't show you anything negative. But it's a good way of showing you that you can have something all the way in the right here, almost. But as long as you have some signal between the two, you can have positive, perfect phase correlation between them. Okay, so enough of that demo. That's just going to be the meters that you can watch as I'm doing this demo. So my next step then is to go ahead and test this with the Blumlein pair. So I'll stop down and reconfigure a little bit here. I suppose I should issue a caveat or an apology. I am a remote recordist, so I don't really record much here in the office/studio. It's a very loud space at certain times. I live downtown Indianapolis, and well, my office is downtown Indianapolis. And I can see interstates 65 and 70 from my window here. They're about 100 yards away. So the din of the constant din of the traffic, semis, and everything else is pretty intense here. I'm running an expander here on my voiceover to just make it palatable for you, but I don't want any processing on the Blumlein pair so you can hear everything as is. This is a very this is not a well-treated room, nor is it silent. So you're going to hear all sorts of room noise and reverberation. I'll try to keep it to a minimum, but I just don't want any processing on here. So that out of the way, let's get going with the demo and see what it sounds like. Okay, so I'm back up and going here. I'm looking right at my Blumlein pair, and I'm at 0 degrees. Again, one mic is suspended upside down over the other one, and the gap between the two mics is right at nose or mouth level, so I'm pretty much centered. I'm right in front of them, which puts me at 0 degrees, top stage center, as I mentioned earlier. So I am 45 degrees off axis to both microphones. And I should sound like I'm in the center, but I'm hitting the front of both microphones. So now I'm going to start turning, and I'm about 18 inches from the mics. So I'm going to walk over now to about 45 degrees around clockwise. So now I'm hitting the direct front of channel 2, but I'm hitting the null of channel 1. So I should sound like I'm 100% right, as close as we can get. So now as I continue around though, now I'm at 90 degrees. I'm in quadrant 2, right in the center of quadrant 2. So now I'm hitting both mics 45 degrees off axis, but I'm hitting the rear of channel 1 and the front of channel 2. So the polarity should be reversed on my signals. I'm going to have phase issues. So my voice should not sound very centered. It will not be like a pinpoint sound. Ambiguous stereo image, I guess you would say. So continuing around to 135, I'm now hitting the backside of channel 1 and the null of channel 2, so I should sound perfectly normal in the left channel only, pretty much. So continuing around to the backside, so now I'm at 180. I'm hitting both mics at 45 degrees off axis, the rear of both mics. Again, that's a good place to be. And now I'm at, let's see, 180, 225, is that right? Yeah. And hitting the backside sweet spot of channel 2 and the null of channel 1, coming around to 270 degrees. Now I'm in the middle of quadrant 4, should be out of phase, and I'm going to skip the rest because you get the idea, just walking around to center again. All right, well, that was a pretty quick demonstration. I think I'll talk about this a little bit more, though, and work through some of the issues and see. I'll do some comparisons here to see if we can fix this or if there's anything that we can do about this to make this better. Okay, so the next thing I want to do here is just to investigate a couple things. So I just made this recording, and I'm not going to listen to the whole thing again, but I'm just going to preview this, and I want to find a portion that's clearly out of phase. And I apologize, earlier while I was recording the Blumlein, you probably heard the echo in my headphones because took them off and they were sitting close to the mic. So hopefully that wasn't too bad, but I'm going to try to put my headphones on now a little bit. I'm going to try to find a place where out of phase, and I'm going to copy this into a new place in the timeline here and edit this and just see if I can work with it and do some comparisons in real time. All right, so I'm going to grab that and paste it. Copy, paste. Put it right here, and let's put a loop on it. Sorry, you're hearing my headphones again. I can't deal with the delay. All right, so we're going to loop this. So now, all right, so we're set up for a loop there. So what I'm going to try here is I'm going to loop this, and as the first time through, we'll just listen to it as is. And then second time through, I'm going to flip the polarity on the second channel of the stereo pair and just see what it sounds like. So then the third time through, I'll start off with both polarities the same and then just flip them on and off just to A-B it a little bit. So let's see what that sounds like. So now as I continue around though, now I'm at 90 degrees. I'm in quadrant 2, right in the center of quadrant 2. So now I'm hitting both mics 45 degrees off axis, but I'm hitting the rear of channel 1 and the front of channel 2. So the polarity should be reversed on my signals. I'm going to have phase issues. So my voice should not sound very centered. It will not be like a pinpoint sound. Ambiguous stereo image, I guess you would say. So continuing around. So now as I continue around though, now I'm at 90 degrees. I'm in quadrant 2, right in the center of quadrant 2. So now I'm hitting both mics 45 degrees off axis, but I'm hitting the rear of channel 1 and the front of channel 2. So the polarity should be reversed on my signals. I'm going to have phase issues. So my voice should not sound very centered. It will not be like a pinpoint sound. Ambiguous stereo image, I guess you would say. So continuing around. All right, so as you can tell, I didn't want to play that through 3 times. It was just too long. You get the idea that the phase issues are just too great to use that, I think. And there's nothing you can do about it. You can't reverse the polarity because that's picking up other musicians who are in the correct quadrants. So I was almost completely done editing this video, and then I thought of something that's can be pretty important here, and that is mono compatibility. There are people who argue that mono compatibility just isn't that important. There are people that say that it's a must-have. Let's face it, we have a very different audio soundscape now in terms of how people are, what equipment people are playing back audio through. So it's anything from, traditional speakers in a living room to car speakers, which used to be, probably the 2 most prevalent, but now lots of headphones and lots of earbuds. And then we even have mono Bluetooth speakers. So, some people really like these. They have some good bass reproduction in some of these little puppies, but they're mono. So what I'm going to do here, I've picked a section here that I'm going to loop. And it starts out, I don't have my diagram up here, but I'm going to start out at 45 degrees. So my sound or my voice should be 100% in the right speaker. So when we fold that down to mono, it should sound okay. In fact, yeah, it should sound very good. But then when I get into that problematic quadrant and I get down to 90 degrees, you're going to hear me in stereo out of phase, but in mono, I'm going to be missing all of the depth of my sound. You're going to hear something that's going to sound a bit like, just room noise. It's more than that, but it's not what you want to hear. So I'm going to loop this just once, I think, and I'm going to start off in stereo, and then you'll see me over here flipping it, A-Bing the mono back and forth. At this point, I'm using the monitoring bus here. So this comes after the master bus. So therefore, stereo phase meter will not be working here, but you'll hear the difference. So again, starting off at 45 degrees, which should be 100% right speaker, I will AB the mono a few times, and then you'll hear me going to 90 degrees, and I'll AB the mono as well. So headphones back on, and let's listen. So now I'm hitting the direct front of channel 2, but I'm hitting the null of channel 1. So I should sound like I'm 100% right, as close as we can get. So now as I continue around though, now I'm at 90 degrees. I'm in quadrant 2, right in the center of quadrant 2. So now I'm hitting both mics 45 degrees off axis, but I'm hitting the rear of channel 1 and the front of channel 2. So the polarity should be reversed on my signals. I'm going to have phase issues. So my voice should not sound very centered. It should have... Okay, so I think I can say definitively that mono compatibility in those two, the quadrants 2 and 4, is going to be pretty bad. So just thought I'd add that. I think that pretty much caps this video. I think I've demonstrated pretty well why I wouldn't use Blumlein pair for such a recording situation. And I can't remember if I mentioned this earlier, but if you're recording musicians in a 360-degree circle, it's going to be a pretty crazy musical experience anyway from a stereo perspective. There's going to be all sorts of crazy... Well... I don't know. It'll be the stereo imaging. I think is going to be confusing. You got a lot of instruments packed in to 60 degrees basically of your loudspeakers. So you could make the point that this doesn't really harm it that much, but I don't know. I think there are other ways to do this that would not require us to just basically give up on 2 quadrants here. I mean, you could ask the musicians to stand in 2 90-degree arcs, but you know, this is a jam session. I don't want to do that. I think this would work perfectly well for the double quartet I talked about earlier. However, these microphones, I should have shown some photos here of my mics. I'm just too lazy to do illustration. I guess I did an illustration. I'm too lazy to do everything else here. These things take me too long as it is. But with the microphones I'm using are Austrian Audio OC818s, and these are not the only mics to do this, but there are several other types of multi-pattern mics that will do this. You know, each mic has 2 diaphragms, and they actually have 2 outputs, 2 mono outputs per mic. So I can take the outputs, dual outputs of these mics, and do a couple different things with them. So number one, well, actually, I wouldn't need this for this. I could try a couple different stereo configs. One would be maybe an Omni mid-side. And I'll get into that. I'm going to do another video on this. I'll try Omni mid-side. I'm doing the same walk around and talking. And then I'll also try a thing where, and this was my first thought of what I would like to do. I don't know whether this will provide enough stereo width, but I could take the output of all 4 of those and just, so maybe channel 1, pan it hard left, hard right, and then put channel 2 front and rear in the center. I don't think I would have phase issues there because... well, I'm not sure. I'm not sure what it would sound like. I'm pretty sure it would sound better than Blumlein. But the other issue here is, obviously, if this is in a loud environment, this is not going to be in a studio, it's a live performance, either outdoors in a noisy place or indoors in a brewery. You're also wanting to try to minimize the room noise and the chatter and the clinking of glasses, most likely, to the extent you can. But when you're recording in the round, there's not much you can do with that. You could potentially use some sort of maybe either an XY from above. If you can get your stereo recording angles right, you're going to miss out on a bit, but it just depends on how high you can get with, you know, knowing your room noise is going to increase the higher you get versus what your stereo recording angle is, how big the circle of musicians is. We know that this is an imperfect situation. I tend to think that either my 4 independent cardioids on my OC818s in the center with all 4 outputs, or maybe even a spaced pair of omnis, because since room noise is everywhere and the musicians are everywhere, why not put a spaced pair of omnis, maybe 30 centimeters apart, right in the middle here? That would be pretty unobtrusive. I've got a couple pairs, or I've got a pair of Sheps that are just like an inch and a half or 2 inches long. That might be pretty nice. The sound would be very good, and again, the separation of the music from the noise of the room is, I'm not going to say it's a lost cause, but the closer you can get the mics to the musicians, the better. So I'm thinking that in the center of the group, right at, chest level, is going to be the best. So anyway, so all that for another day, I guess.